Hello everyone, this is Prem Kumar. In this video, I'm going to explain you how to use a queue processor rule in Pega. In the last video, we already saw about the standard agents, and from Pega Infinity version, queue processor is set to replace this standard agent. I'm here to promote my video course, the Pega Masterclass. There are many students actively learning with my course material. If you are a fresher, beginner or an intermediate, or if you are preparing for some interviews, definitely my course can help you with the preparation. Because in the course I have covered almost everything, like from the basics to all the advanced level. So I would say do not miss it. You can enroll at the earliest possible. So first, let's start with some of the main differences between the standard agent and the queue processor. The first main difference is on the database transactions. In the last video, we already saw that with the standard agent, we need to use all those queue instances into the database table instance, right? Either we can use the default system queue default entry instance, or we can create our own system queue instance, have a dedicated table for it. But at the end, all those queue instances are going to saved into a database table. But with the queue processor, we are going to use the Kafka data. So with Kafka, we will have separate topics for each of the queue processor, and under the topic we will have partitions, and the data can go into different partitions. Offsets can be maintained. So do you think that we will never use these database tables for this queue processor? The answer is no. We will use the database tables in some situations. One example is on the delayed processing. If you want to process the queue instance in a delayed manner, then the instances first get saved into a dedicated database table, and only when the time is reached it get published into the Kafka topic, and then queue processor can process the data. So this is one way to get the data into delayed table, and the other way is when the stream service is down. I will explain it in detail as a next point. But just understand that to run a queue processor, you need the stream service, and if the stream service is down, the data doesn't get pushed to the Kafka topic. Instead, it gets saved into the database table as a delayed item. So these are the ways how the data can saved into delayed item. And then the broken item. If the queue processing gets failed, then the data needs to be persisted at some place, right? So Pega uses a dedicated table to persist the broken item. So definitely, with the queue processor also, we do use these database tables for the support, but the main processing is with the Kafka data, and that is why the Kafka processing is much more quicker than the database processing. So when I refer Kafka topic, what I really meant is, if you go to your personal edition install directory, go to Tomcat, there you will find the Kafka server running as well as the Kafka data directory. Go to the Kafka data directory, there you will find all the topics. These are all the topics and the partitions. As you can see, each of the topic currently has 6 partitions. I would expect the default value should be 20, but I feel there is some kind of server restart, something got messed up. But just understand that if you take an example of PZ standard processor, you see this is a partition of the same topic, different partitions are there. So for each of the queue processor, Pega have a topic and multiple partitions are created, and the data can go inside this partition. So this is where the Kafka data is stored. So always do remember, this should be persistent. If this data gets cleaned up in production especially, you may miss a lot of data. This you can just think it of like a database table. Deleting a database table in production is not the common one which we will do. Similarly, it's not recommended to delete this Kafka data directory in production. So this is what I meant about the Kafka topic and the partitions. And then I also talked about the delayed item as well as the broken item. If you go to the App Explorer and then if you go for system message, then under queue processor you will find two classes. Two are concrete classes, the broken items as well as the delay item. If you click here, for now you will not find any items because I never tried anything in the queue processor in my personal edition. But the thing is, if you look at the class of these things, it gets mapped to a dedicated table. So these are the class instances which stores the delayed item as well as the broken item. You can also check broken item yourself. So you see it goes into PRSys delayed queue table into the Pega data schema. And then few more important thing to understand is, If you go for the App Explorer again and then search for Pega DM decision data flow -work, what Pega does is it creates a data flow instance for each of the queue processor. As you can see, these are all the queue processor runs. If you just scroll to the very last, you will find that for each of the queue processor, you will have at least one data flow run if the queue processor is actively running. Let me give you an example of py send email. Click this one. You will find the data flow run. It started on 4th of July. It is running for the last 43 days. And currently I never send any email out from my Pega application. That is why you find the records as 0. And you can also use this to check how many records came in, how many output, and what are the successful records, what are the failed records. These are all more related to the data flow. In Pega, data flow is also a rule. So you can also schedule a run for the data flow and then you will find the same thing. So what Pega does with the queue processor is for every queue processor, it also creates a data flow run. This is what I want to explain you, and the offset and all the statistics of these topics, the partitions are all stored into the database table. If you go for the PR data decision DF part table, there you will get all the data flow partition details. You can see how many records were processed recently, the loss IDs, all these metadata, the Kafka related metadata gets persisted into the database table. So these are the main points. Just a small recap. We saw that for every queue processor, Pega creates some topics and partitions into the Kafka directory. And in Pega, we also have two concrete class instances. One is a delayed class instance and the other is the broken process class instance. And then we also see Pega also create for every queue processor a data flow run, and all the statistics get saved into this dedicated table, PR data decisions DF partition or part. Okay, now coming back to the differences. Now we know the database differences, how the data are stored between the queue processor and the standard agent. Now let's look at the second main difference. Queue processor is totally dependent on the stream node, whereas the standard agents is not dependent on stream node. What I meant here is queue processor, it needs the Kafka stream, and Kafka stream runs on the stream server, because in the stream server is where the Kafka is installed. So definitely you need to have at least one node classified as stream. So where do we do all these node classifications? Still I haven't explained that in any of the video, but just giving you some short summary. If you go to the Admin Studio overview button and then click on View Systems and Nodes, that will give you what are the node classification done for the current server. As you can see, current server, that is under my own personal laptop, has the node type as stream, background processing, web user and such. So all these four node types are classified for my single personal server. In production, you will have different servers and different servers will have dedicated node classified. And also we need to make sure that stream service is up and running for queue processor to work. To check that, you can go to decision, infrastructure, and then services, stream. If you go here you should find the stream nodes as status normal. You can always stop it and also you can decommission it. So whenever a stream node is stopped or decommissioned, so what happens is when a new message comes to the queue processor, it always goes to the delayed item. It doesn't goes to the Kafka topic. Only when the stream node is up and running, Kafka topic can be used and can be processed by the queue processor. And the final main difference is on the performance improvement. Pega claims that queue processor runs much more faster than the standard agents. They support high scale throughput and they also support the multi-threading. In the queue processor rule form, you can configure the multi-threading option, and this multi-threading option is dependent on the partitions. For example, if your Kafka data has 20 partitions, then at a maximum you can have 20 multi-threads running. You can't have more than the partition value. Okay, now it's time. Let's go to Business Studio. Check the out-of-the-box queue processors. Then we will also talk about the two types of queue processor, which I never explained till now. There are two types of queue processor. One is the standard queue processor and the other is the dedicated queue processor. And queue processing can be done in two ways. One is immediate and the other is like a delayed one. We will see all these in a short time. Let's go to Business Studio and find it out. So I just logged into the Business Studio. So first let's find out the out-of-the-box queue processor instances. To check that, you go to Records, sysadmin, and then scroll to the queue processor and click on it. That will list you the existing queue processors. As you can see, all these are out-of-the-box queue processors. I never created any queue processors till now. Let's look at this queue processor PY process notification. I'm going to concentrate on this and show you how this really works. Let me open this. So what this PY process notification does is, it is running on background processing, and all these things we will see little later. But the main thing is like, it uses the activity PZ process notification and uses the class system queue notification. Just remember that the same notification was there before as a standard agent, and now it is getting used as the queue processor. Okay, now since it is getting used as a queue processor, definitely the topics and partitions should be created, right? Let's verify that. Go to the Kafka directory, and I already found one process notification because I just tested before. So I see it one at the top where my data went into the third partition. But if you scroll down, you will also find a lot of process notifications like 0, 1, 2, 4, 5. So there are 6 partitions for this queue processor topic, and 6 partitions are there in the Kafka data directory. So this is good. The next is we will check the data flow run. So to check the data flow run, as I told you, use the Pega DM data flow run work. Click on it, and then you can open the PY process notification one. Just click on it. There you will find the data flow run. Again, it is running for the last 43 days, and it processed one record. That processed just today. I was testing, as I told before. So it just processed only one record. Okay, just keep a note that that is one record process, and that is processed by the partition number 3. Now if you go to the database table, and then let's focus our query especially on the PY process notification. If you just run this, you will find there are 6 partitions, as you can also find it in the table, and you find there is one record process, and that is on the third partition. Okay, now we are a bit clear with all this data, the existing data. Now let's create a new notification and see how this queue processor processes it. To create a new notification, what I'm going to do is I'm going to use the out of the box activity px notify. Just open this activity, and then you can run this activity. So I'm going to just run this activity. The notification name, I'm going to use py case details, and the context class is going to be alive client app, and the context key. Here I need to add this notification to a case, so I have to open any existing case. I'm going to use the last created case, so I will get the p0 key of the last created case from here. So this is the p0 key. I'll copy it there. And then you can also specify the recipient list, like whom you want to send the email. Currently I'm not going to do any configuration on that. And then you can also choose to commit it. Since we are going to run this activity individually, I'm going to use the option of commit, so that this queue instance will get persisted, and then it means like it goes to the Kafka data and our queue processor can easily process it. Now I'm going to run it. I get a success message. That is very good. Now the next thing is, let's check it from the data flow run. If you go to the data flow run, so already you see it processed 2 records. Now let's look at the same, like under which partition it got processed. If you go here, and then if you just use the modify date time, there you will find now this time it is processed by the partition 0. Before it was processed by partition 3. Let's also verify the same from the Postgres console. Now if I run it, I should see for 0 as well, there is one record processed. As you can see, one record on 0, one record on 3. So this queue processor, it works perfectly fine, right? It processes the record. Whatever queue record we just sent, it processes the record. Now there are 2 things which you need to do. First, you need to have a queue processor instance, and the second, you need to know how to queue an instance to the queue processor. Already we saw the same kind of workflow. We saw how to create a standard agent. Then we also saw how to queue an instance to the standard agent. We know that we can use the queue for agent activity or queue for agent method. Similarly, for the queue processing, we have queue for processing method. And then we also have a smart shape that can run in background that uses the queue processor. Okay, now let's go to Business Studio and create our own queue processor. The business requirement for this queue processor, I'm going to use the exact business requirement which I used in my previous video, where I want to send out notification, the onboarding notification I have to send out. Let's first start with creating a new queue processor rule. Use the create menu, sysadmin, and then queue processor. So I'm going to say send So here you need to provide an identifier, and one more technical difference between the standard agent and the queue processor is, for standard agent we create a rule set, and inside the rule set we put all these agent activities or the agent names. So as a whole we call the rule set as the agent rule, but with the queue processor we will create dedicated queue processor instance, queue processor ID we provide them, and it is not tied or not grouped under one rule set. Technically yes, we provide the rule set, but unlike the agents where we call the rule set as the agent name, queue processor we just call the queue processor name alone. So this is the queue processor name, create and open. Now let's find the configurations that you can do into the queue processor. It contains one single main tab, and there you can enable or disable the queue processor. By default it is enabled. And next is associated with node type. You can associate the node type, like under which node type you want to run this queue processor. We already saw during the standard agents lecture also, we can associate agents to the node type so that it runs only on the servers that are classified based on the node type. Here also similarly queue processors can run on this background processing node type. Now don't confuse with this background processing node to the stream nodes. Stream node is where Kafka runs, but it is not necessary that queue processors also need to run on the stream nodes. Queue processor can always run on the background processing node. Next is when to process, whether you want to process immediate or delayed. From the name itself we can say if you want to quickly process, then it is immediate. If you want to have it delayed, you can very well have it. Pega saves the instance as a delayed item instance. We already saw a class is there dedicated, and a table is there that will hold the delayed item. For now I want to just show you how the delayed items work, because for the POI process notification we already saw it is immediate. It just quickly processed everything, right? But now let's check the delayed part. So I'll use the delayed configuration here, and the number of threads per node. Here as per my current server configuration I have only 6 partitions, we already saw. So I can have maximum 6 threads per node if I have only one node. Currently my personal edition is the only server or one node, so I can have maximum of 6. If I have 2 servers or 2 nodes, then I can have maximum of 3. 3 into 2 is equal to the maximum partition, that is 6. So by this way you can have number of threads per node. If I give like 20 threads here, that is irrelevant, because then there is only 6 partitions are there. So I cannot use this 20 threads there. So just give it the right value. Here I'm going to just specify 6. Let's check how it works. The default value is always 1. And then processing activity, this is the main thing. Definitely queue processor needs an activity. Similar to how we saw for agents, queue processors also needs an activity. Now I will use the same activity here. My activity is send onboarding notification, and if I open this activity it just logs a message with the POI ID. I'm just going to use the same thing here. I'm not going to send out a notification using connector or something. Just for this demo purpose I'm going to use the same activity. And then the retries, the error mechanism, maximum attempt. Similarly how we saw for standard agent, we can also provide maximum attempts, but we have some kind of additional configuration. You can set initial delay in minutes. It means let's say it failed, then it always use at least 1 minute to try next time. So initial delay will be 1 minute, and then you can also have a delayed factor. So what I meant here is, let's say at 4 o'clock the queue processor processing, it went into error. So the first check will be on 401, that is the initial delay, and the next check will be on 403, because it will be like initial delay into delay factor. So next time it will try only after twice of the previous time. It means like it will check on 403. Even if it fails, the next time when it checks is, previous time it was 2 minutes, delay factor is 2 minutes, 2 into 2, 4. Next time it checks only after 4 minutes. So first time it checks after 1 minute, next time after 2 minutes, next time after 4 minutes. This keeps on moving. And finally there are some kind of alerts you can generate based on some threshold. Pega has this out of the box alerts that can get generated. So you can configure your queue processor settings here. If you say like 2000 milliseconds is needed for long running queue process threshold. If the queue processor runs more than this 2000 milliseconds, then an alert will be generated. So you can configure it based on your requirement. If you really find the queue processor needs more time, you can very well adjust here, but just adjust correctly, because you don't want to get the alerts getting flooded there because of the configurations here. So these are all about the queue processor configuration. And one important thing which we are missing is, on the standard agent we saw there is a security tab where we configured the access group. So what is the access group for this queue processor? Let's find it out. Just do a save here. As soon as you do a save, you see all queue processors are rule resolved against the context specified into the system runtime context. Open this one. So in the system runtime context, you need to have your right application there. Our queue processor is under this clients app application. So clients app application should be there under the system runtime context so that our queue processor can be activated. If I don't specify the clients app application here, our queue processor will never run. So definitely you should have the system runtime context here. As well as the access group context, it uses from the user who queues the entry, it uses the same access group unless that is customizable from the activity method, which we will see now. So for now, what we did is we created a new queue processor instance. So one step is done and this queue processor is already running. Let's verify that. If you go to the admin studio and then switch to the queue processors, there you should find the newly created queue processor. If you don't find it, just do 1 or 2 refresh. Here I already found that send onboarding notification is under the queue processor and then it is already running. As you can see, the status for this is running. During the end of this video, we will check how to debug this queue processor. But first, now let's concentrate how to queue an entry to this queue processor. As I told, there are 2 ways you can queue. One via the activity method and the other via the flow rule. Before that, let's also verify the new topics and partitions that are created for the new queue processor. So go to the directory under the Kafka data. You should find the newly created topics and partitions. As you can see, 6 partitions are created for the send onboarding notification. And you should also see the data flow run. If you go to Pega DM DDF work and check for the instance, the latest created instance should be send onboarding notification. Click on it. There shouldn't be any records running, but you also see it is running for the last 4 minutes. Processed records is 0. So we are all good. All this configuration and setup is done. If you want, you can also check the same from the database table. I'm going to just show you. There are 6 entries here. First, let's explore how to create a queue instance from an activity. To do that, go to Records, Technical, and then open any existing activity. So I'm going to use this create onboarding notification queue. We already used this for the previous video where we use the standard agent. Now I will comment that step and then I will include a new step where I can queue for the queue processor. So I'll add a new step here and then say queue for, instead of agent, there is a processing is there. So you can specify the processing. And then there is one important configuration which I never explained you. I purposefully did because I want to show you after this. You have 2 types of queue processor. One is the standard queue processor and the second is the dedicated queue processor. So what is the main difference between the standard queue processor and the dedicated queue processor? Standard queue processor is little bit similar to system queue default entry, and dedicated queue processor is like system queue service level, system queue schedule task and these things. So with standard queue processor, you don't want to create any new queue processor. You can use the existing queue processor. All you have to do is just create an activity and then use the existing queue processor. It means it will use the existing Kafka topics, Kafka partitions, data flow run, and the run will happen using the existing queue processor. It just uses the activity. That is called standard, and you also get an alert here saying that because whenever you use standard queue processor, it is going to use a shared topic. So when you have huge amount of data, definitely it may have impact, because let's say in your application at 5 places you are using this standard queue processor or shared queue processor, then definitely there can be some impact, right? So if you find you are going to process with huge volume of data, always go with dedicated queue processor. I'm going to use dedicated queue processor for now, but I'm also going to show you how to use the standard queue processor. First, let's go with the dedicated queue processor. Use the newly created queue processor. And then as you can see, this is a delayed queue processor. You can process the date time here. So you can say current date time. So what I can say is I want to process this after 10 seconds maybe. So I'll use some existing function here. I'll go to the date time and then add to date. So what I'm going to do is current date time, I'm going to add 30 seconds. So add to date. And then if you look at the format, it uses all the strings, the date, days. So date will be add. So here you can add the current date time plus 30 seconds. So it's the days is going to be empty, hours empty, minute empty, and seconds is going to be 30. You can also test this easily. You see here, this is the current time, and you see it just added 30 seconds. So we are good now. I'll add this here and then do a save. The next method parameter is on lock. Remember, again, during the standard agents, we know how to occur lock, because definitely when we want to use the claims records case, we need the lock, right? So we need to get the lock, and using queue processor, you need to explicitly specify how to get the lock. You can get the lock using primary page, it means the step page. Otherwise, you can also define the keys like PYID or different key. So Pega will automatically try to open the case and get the lock from there. So you can also find the help tip here. It's very nicely explained. As you see, primary page, it opens using P0INS key and occur the lock from the primary page. And remember, this primary page is available to processing activity as PYQ page. The next is key defined page. It says like it uses the key to lock. It is available as PY other page. And the third option is if you don't want to have lock, we don't want to have it. If you are working with the queue processor with some external Kafka data, definitely we no need to have a lock on those data. So in such situation, you no need to have the lock. But when you are working with the Pega classes, then you can specify the lock here. I will use the primary page, and under the advanced configuration, you get few more configurations. The first is queue immediately. It means like commit. You don't want to defer save. If you not enable this option, then it will be like a deferred save. It wait for the commit operation. But if you enable this operation, it will automatically get committed. It means the queue instance will be automatically saved. The next is queue current snapshot of the page. This will be used only when the lock is none. When you use the lock is none, this will be enabled. So if you want to take a snapshot of the current primary page, you can send it to the queue processor's activity by using this option. Otherwise, if you really need a lock, you can very well do it, because when you have the lock, this page will also be there. But whatever details it gets updated will always be refreshed data to the queue processor activity. If you really need the snapshot, then you can use the other option. Timeout to occur lock. If you are using lock, definitely you need to have some kind of timeout, which you can configure here. And finally, this is one of the interesting configuration. You can also specify some alternate access group. Currently, the current access group will always be the user who queues the instance. If I run this activity, my access group will be used just like how it is for standard agent. But if you want to have alternate access group, you can very well do it by configuring here. So these are all the configurations about the dedicated queue processor. If I just change it to the standard queue processor, definitely you will find that it doesn't ask for the queue processor name, because it is going to use the out of the box standard queue processor. And all you have to do is just specify the activity name, use the lock, and all the advanced configuration same. And then you can also configure or adjust your threshold limit or the alert generation threshold limit. First, let's go with the dedicated processor, do a save. Now I just use queue immediately. So definitely a queue instance should be created, and this should be processed by my queue processor. I'm not going to run this activity for now, because my primary page and all these things I have to populate. Instead, I will use the other option of calling the same thing from a flow shape. I hope here you understood how to do it. Let's do the same thing in the flow rule. For the flow rule, I'm going to use the create stage flow. Go to claims request, and from here you open the create flow. And we already have a shape here that queues for the standard agent. So what I'm going to do is I'm going to remove that shape. I don't need to queue to standard agent. Instead, I want to queue it to the queue processor. To do that, you have a dedicated shape, the automation shape, run in parallel or run in background, sorry. Use this run in background and then connect it and then configure the shape. That's it. Now click on here. What type of queue processor you want to use? I'm going to say dedicated queue processor, and then specify the queue processor name, date time for processing. I'm going to use the same thing which I used in the activity. I'll use this expression here. Since there is no expression builder, I'm doubting it may throw some error, but let's check it. Lock using primary page is fine. I'm not going to use any alternate access group. Do a submit. So it threw some error. So what I'm going to do is I'm going to initialize this value into some kind of property. So to do that, I'm going to use the post data transform, because I cannot use the data transform in the connector of a screen flow. So instead, I'm going to use this flow action, and the post data transform of this flow action I'm going to initialize. I'll quickly do it. Please follow with me. So here I'm just initialize it to an out of the box datetime property, and I'm going to use the same property here, datetime property. And then you can also map the item ID to the property. Item ID refers to the message ID. So what I can do is, for now, I'll use another temp property. I'll use the temp text that will hold the message ID. Ideally, you can have your own dedicated property to store it. That's why you can just track it and see how the message gets published and how it got processed. Now I'll save this. Let's run the new case and let's see if our first queue instance gets created. You can also trace if you want. So I just did a submit. It went to the next stage. Now to check, first I'm going to check from the data flow run. Send data flow. You should have at least one record here, and it is not there. I think you know why. Because we created it as a delayed queue processor. So definitely the instance should be on the delayed queue processor. Let's verify that. You see here the message is 67BD. It ends with 67BD. Now if I refresh this delayed item again, this message gets disappeared. It means we had a time of 30 seconds, right? After 30 seconds, it gets published to the Kafka. Now let's check the data flow run. If you go to the data flow run of the onboarding notification, you see it processed the first record. The first record gets processed here, and it has been successfully processed. Now let's check the log message. You see here sending onboarding notification for case C4046. We also had the same case here, C4046. So we have successfully created a dedicated queue processor that is of delayed type, and then it executed an activity based on the delayed queue instance. Now we will also try the same but using a standard queue processor. So first, to understand that standard queue processor, what I meant here is, if you go to the queue processor, there you will find PZ standard processor. So this is the standard queue processor. So we are going to use this queue processor and the topics and partitions from this queue processor. So let's go to the flow rule. Just before that, we will verify the topics and partitions. If you go to the topics and partitions, you will find that send onboarding notification 4 got used, and then we will also see the standard processor. Third is the latest one that processed. Okay, now let's use the standard processor. Go to the process flow and then update the run in background from dedicated to standard, and then use the same activity. Just say send onboarding notification. Remember, this activity is not using queue for processing. It is the main activity that is used in the queue processor. So instead of having this activity into the dedicated queue processor, I'm using it into the standard queue processor, and then I will use the same primary page stuffs and then do a submit. Now again, if you create a new case of 4047, click submit, and the case moves to the next stage. Now the first thing is, it should be automatically processed by the standard queue processor. Let's verify the topics first. In the logs, I can already see send onboarding notification for case 4047. Let's verify it from the admin studio. In the PZ standard processor, I'm going to check the data flow run for this, and it processes a lot of records, but definitely our record is also one of the record. By this way, you can use the standard queue processor if you don't have a huge volume of data and you don't want to create your own queue processor, own Kafka directories. Then you can very well go with the standard queue processor. I would recommend you, whenever you have something to update millions of records but only once at a time, you don't want to create a dedicated queue processor for it. You can just run it using the standard queue processor, maybe at night time when end users don't log in. That is the preferred time where you can run these nightly batches or like a bulk update which you can do during the off hours. And now let's look at the final point, how to debug the queue processor. Just like how we can debug a standard agent, we can also use the admin studio to debug the queue processor. So you go to resource and then queue processor. From here, you can do a lot of stuffs. You can stop the queue processor, or you can also trace a queue processor. Finally, from here also you can view the data flow run. You don't want to go to App Explorer, Pega, DM, DDF work. Instead, you can just go from here, check the data flow run, and from here you can check how it is processing. We also have some kind of APIs that helps to start this queue processor. If you go to Admin Studio, Resources, and then switch to API, there you will find a rich set of APIs. Here I have already scrolled down to the System Management API. You already find there are some kind of APIs that helps to start, restart, and stop agents. So agents can be standard agent and advanced agent. as well as you have it for the queue processor. As you see here, this block is specially for the queue processor. It can get the list of queue processors, it can start the queue processor, as well as it can stop the queue processor. Now one more final thing I want to say before I end this video is like how to replace a standard agent with the queue processor. If you look at here, there can be two situations which you may get. For example, if the standard agents, they process only the real-time messages or real-time queue entries, it means there is no future entries to get processed. In such situation, it is pretty simple. What you have to do is just create a new queue processor and mostly with the same activity. And then the next step, you have to find the references at places where you use the queue for agent and then just replace it with the queue for processing and give your own queue processor. If you are using the standard queue processor, you can very well do it. And finally, you can also disable the agents from the agent rule form. So this is pretty simple because you will not have any kind of scheduled queue instances. But there can be second criteria where your standard agent can be processing some kind of delayed messages. Like some of the queue instances that get scheduled like 2-3 days afterwards. In such situation, what you can do is you can follow the first two steps. You can create a new queue processor, you can put the activity there, and then you can change every place wherever you use the queue for agent into queue for processing. But you cannot straight away disable the standard agent. You have to wait until all the queue instances are successfully processed by the standard agent. And if there are no more queue entries waiting for the standard agent, then very well you can disable the standard agent. So these are all the things which I want to explain you in this queue processor video. I hope this is informative. Now you know the main difference between the standard agent and the queue processor. In the next video, we will shift our focus into the advanced agents followed by the job scheduler. See you in the next video.